Our previous video we have discussed about the theoretical part of polynomial from chapter 1. Okay, now we are going to discuss about the problematic parts of this chapter. So the topic is graph of quadratic polynomial. Regarding this we have three cases. First of all, the standard form of a quadratic polynomial is ax squared plus bx plus c, okay, where the necessary condition is this: a is not equal to 0. It has two zeros, alpha and beta, and its degree is 2. So case 1 is this: when this polynomial px is factorizable, okay, into two distinct linear factors. For this, the discriminant d is greater than 0. Discriminant d is equal to v square minus 4ac. In this condition, or in this case, it has two zeros and its graph is in two possible positions, number 1 and number 2. Here we can see clearly it cuts the x-axis at 2 points a and a dash, similarly b and b dash, so it has two zeros. Got it? According to the conditions. These are two examples for your practice. We can verify this condition with the help of these two examples to find their discriminant. Discriminant will be greater than 0 or positive. So it is verified by this. Okay. Now case second, where px quadratic polynomial has two equal factors or two equal zeros. In this, the condition for the discriminant is equal to 0. So it has two equal or same zeros, or it cuts x-axis at 1 point. Got it? Its possible graphs are as follows. First figure is this and second is this. You can see clearly it cuts x-axis at a single point. Got it? So it has 1 0 according to the graph. Is that clear? Now, two examples are also there for the verification of this case. You can verify it. When you find the value of discriminant d, it comes 0 in both the examples. So you can try it and verify it. Got it? Now case 3, where px, a quadratic polynomial, is not factorizable. For this, the discriminant is smaller than 0 or d is negative. Two examples are also there for the practice. The value of d comes negative and the position of graph like this. There are also two positions where the graph doesn't intersect or touches the x-axis. Got it? Now, standard form of a cubic polynomial. What is the standard form? Px is equal to ax cube plus vx square plus cx plus d, where the coefficient of x cube is not equal to 0. It has three zeros, alpha, beta, gamma, and the degree of a cubic polynomial is 3. Now some formulas related to this are: sum of three zeros, alpha plus beta plus gamma, is equal to minus b upon a, where v is the coefficient of x square and a is the coefficient of x cube. Next formula is sum of the product of the zeros, taking two zeros at a time. So we can write like this: alpha into beta plus beta into gamma plus gamma into alpha is equal to c upon a, where c is the coefficient of x and x cube is the coefficient of, a is the coefficient of x cube. Next, product of the zeros, alpha into beta into gamma, is equal to minus d upon a, where d is the constant term without variable and a is the coefficient of x cube. Now, some formulas from biquadratic polynomials whose degree is 4 and it has 4 zeros, alpha, beta, gamma and delta. This is the symbol for the small delta. This is also known as small delta. And standard form is py is equal to ay to the power 4 plus vy cube plus cy square plus dy plus e. And necessary condition is where a coefficient of y to the power 4 is not equal to 0. Sum of the all four zeros of this polynomial alpha plus beta plus gamma plus delta is equal to minus b upon a. Again, b is the coefficient of y cube and a is the coefficient of y to the power 4. Sum of the product alpha beta, beta gamma, gamma delta plus alpha gamma plus beta delta is equal to c upon a. C upon a. C is the coefficient of y square and a is the coefficient of y to the power 4. Got it? Taking two zeros at a time, we can write this formula like this also. Got it? Now, the third formula. Taking three zeros at a time as a product, and when we find their sum like this, alpha beta gamma plus beta gamma delta plus gamma delta alpha plus delta alpha beta is equal to minus d upon a, where d is the coefficient of y and a is the coefficient of y to the power 4. We can write this formula like this also. Alpha beta is common here, so alpha beta gamma plus gamma delta alpha plus beta is equal to minus d upon a, where d is the coefficient of y and a is the coefficient of y to the power 4. Now, product of all four zeros, alpha into beta into gamma into delta, is equal to e into a, where e is the constant term and a is the coefficient of y to the power 4. Got it? So, in words, we can write these formula like this also. Now, next concept is division algorithm. We can earlier discuss in chapter 1, we have discussed in our previous chapter 1, real numbers, Euclid's division algorithm or Euclid's division lemma. This is the same lemma is for algebraic expression. So this is known as division algorithm. We also know that long division method by the other name of it. Got it? It states that for any polynomial px where gx is a non-zero polynomial and two other polynomials qx and rx are there, such that px is equal to gx into qx plus rx, where the rx is equal to 0. And the condition for rx, the degree of rx is always smaller than the degree of gx, where gx is the divisor polynomial, this is the dividend polynomial, this is the constant polynomial, and this is the remainder polynomial. All are algebraic expression in terms of the variables and numeric terms. Got it? So this is the problematic part of this chapter. Now we will discuss some problems. Those I will give related to this video later. Okay, after this video you can discuss the problem related to this chapter to me in the group anytime. Okay students, have a good day.